Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we move to the ideal gas law. It is actually the equations that express the relationship between the volume, pressure, temperature, and also the amount of the ideal gas. This ideal gas law is actually the combination between the laws that we have discussed before, which are the Boyle's law that express the relationship between volume and pressure. Then it combined with the Charles law that express the relationship between volume and the temperature of the gas, and also Avogadro's law, which express the relationship between the volume occupied by an ideal gas with the amount of the gas. So the combination of these three laws leads to the ideal gas equation. If we combine these three, we will get V directly proportional to Tn over P. And if we rearrange this equation, and we move P to V, we will get PV is directly proportional to Nt. P is the pressure, V volume and amount, and T is temperature. And when we change this directly proportional symbol to equal symbol, so we are supposed to add PV equal to K constant and T, or to be specific, K is the general constant, and this equation is the ideal gas equation. We are using R as the ideal gas or as the gas constant. So for the calculation purposes, when we want to use this PV equal to nRT, we have to make sure that the unit of the pressure, volume, R, the gas constant, and also T, temperature, is at the correct unit. They have to be tally with the unit of the R, because we have several values for the gas constant, and different value for the gas constant will lead to different unit. But the most common R value that we use is 0.0821 atm liter mole negative 1 K negative 1. Let's look at to this example. How to apply the PV equal to nRT or ideal gas equation. We have C2F4H2. It is a compound that used in the air conditioner. If 2.5 gram of this compound is introduced into 500 ml container at 10 degrees C, what is the pressure in atm is developed? Let's look at the information that we have. We have mass 2.5 gram, and then volume 0.5 liter, temperature 10 degrees C or 283.15 K. Then the R is given here. Then the question wants us to calculate pressure in atm. We know that we have to use ideal gas equation. So check the information that we have. We want to calculate P. We have volume. We have R value. We have temperature, but we don't have mole. But what we have is the mass. So first step is to calculate the number of mole. So N is equal to mass over molar mass. So the mass of the compound is 2.5 gram. Divide with its molar mass is 115.025 gram per mole. That we will get the number of mole is equal to 0.7987 mole. So we already have our N. We can calculate the pressure, make P as the subject. So P is equal to nRT over V 0.7987 mole multiply with R 0.08206 atm dm cube mole negative 1 K -1, multiply with the temperature 283.15 Kelvin, divide with the volume is 0.5 dm cube. So we know that liter is equal to dm cube. So here when the volume is 0.5 liter, it is 0.5 dm cube. Then we press the calculator, we will get the pressure exerted is 103 atm. This ideal equation can be used to determine the molar mass and also the density of a gas. By rearranging the ideal gas equation, PV equal to nRT. So this is because N is the number of mole and N is equal to mass over molar mass. So if we plug in this N, substitute with the mole in the calculation in the equation, it will be PV equal to mRT over mR. Okay, so this is actually N. So if we want to determine the molar mass of the gas, we make it as the subject. So we will get the equation mR is equal to mRT over PV. So this is if we want to determine what is the molar mass of the compound. If we want to determine the density of the gas compound, we know that the density P, rho, is equal to M over V, mass over volume. Okay, so we will make M over V as the subject. Okay, we make this as the subject so that we rearrange the equation. It will be equal to mR P over RT. Okay, so the density is equal to pressure multiplied with the molar mass over RT. So let's look at to the application of this equation. Calculate the density of the ammonia in gram per liter at 0.989 atm and temperature 55 degree C. Okay, so since that we want to calculate the density, so let's use the equation. Density is equal to P mR over RT. So pressure is given as 0.989 atm. Multiply with the molar mass of the ammonia. We know that the molar mass of ammonia is 17.04 gram per mole, over R is 0.08206 atm. Liter, mole -1, K -1. Okay, why this time we are using the unit, the volume unit of liter? Because the question said that they want the density in gram per liter. And then multiply with the temperature is 55 degrees C. So 55 degrees C is equal to 328.15 Kelvin. Okay, make sure that we change the temperature unit to Kelvin. So now we can cut ATM with ATM. Mole -1, mole -1, K with K -1. So what's left is gram per liter. Then we press the calculator. We'll get the answer is equal to 0.626 gram per liter. Okay, the next example. Okay, when we want to determine the molar mass of the compound. Okay, so when we determine the molar mass of the compound, at the same time we can identify the unknown gas compound. Okay, in this case, okay, let's look at to the other information that we have. The density is given 7.71, temperature is 36 degrees C, pressure is 2.88 atm. If let's say you are not sure which equation that we have to use, then just take out the information that is listed in the question. So the first one is density, 7.71 gram per liter. And then we have temperature 36. We know that we have to convert it to Kelvin. So it is equal to 309.15 K. And then the pressure 2.88 atm, and of course that we know our R is 0.08206, and we have to calculate the MR. So we know that this is the application of the ideal gas equation, okay, that is derived from PV equal to nRT, okay, and is a M over molar mass. So we will get the molar mass is equal to density RT over pressure. So density is 7.71 gram per liter. R is 0.08206 atm liter. Mole -1, K -1, multiply with the temperature is 309.15 Kelvin, 2.88 atm. We cut atm with atm, K -1, liter -1 with liter. So what's left is gram per mole. Then we press the calculator, we'll get the molar mass of this compound is 67.95 gram per mole.